What is a star? When we look up at the night sky, we see thousands of points of light. You can see these in patterns in the night sky called constellations. We think that there are around 100 billion trillion stars, all grouped inside about 200 billion different galaxies in the universe. But what are these objects? What are stars? In space, stars are massive glowing balls of extremely hot gas called plasma. The Sun is our closest star. Although the stars look small in the sky, they are massive objects, millions of times larger than the Earth. They look small because they are very far away. Stars form in huge clouds of gas and dust called nebulae, sometimes known as star nurseries or star-forming regions. When the clouds are disturbed by nearby events like supernova explosions, they are triggered to start moving. Some parts of the cloud clump together and become denser. The gravity of the gas and dust in the dense parts of the cloud pulls everything inwards. Clouds slowly collapse into several points or cores. Deep in the centre of these cores, there is lots of material squashed together, and it's very hot. Eventually, it will be hot enough for nuclear fusion to start. Nuclear fusion is the process that powers a star. When fusion starts, the star begins to shine. A new star's sudden burst of light blows away much of the nearby gas cloud. However, it can leave enough material behind to form a number of planets. Stars are not all created the same. Some are much larger than others. Our star, the Sun, is a fairly average star. Some stars are just 10% of the mass of the Sun, and the most massive stars we know of are about 200 times the mass. The most massive stars shine for many millions of years. A smaller star, like the Sun, will shine for around 10 billion years, but no star lasts forever. After formation, they go through several stages, which we call the life cycle of a star. How a star lives is a dance played out in the balance of forces: outward energy from fusion versus gravity pulling the star inwards. During a star's life, it continues to make energy by fusion, and when the star's fusion ends, it either explodes or slowly fades. During either process, the elements created inside the star are sent out into the universe to make new stars and planets. Almost all the elements you find on a periodic table were once created inside stars. We can take special observations of stars called spectra. These split all of the light into a range, each with a very slightly different wavelength. By looking at the bright and dark parts of these spectra, we can see the imprints of the different elements inside the star. There are so many stars, but they do not all look the same in the night sky. Astronomers began categorising stars hundreds of years ago based on their mass and temperature. We try to measure the star's mass by looking at how bright it is, with bigger stars looking brighter in the sky, but measuring brightness in space isn't easy. How do we know if a star is bright because it is close to us, or if it is bright because it is massive but far away? Astronomers use magnitudes to describe the brightness of an object. This is a way to compare stars with each other. There are two types of magnitudes, absolute and apparent. This is because how bright an object in space looks depends on how far away from Earth it is. The apparent magnitude is how bright the object looks from here on Earth. The absolute magnitude is how bright the stars would be if they were all placed at the same set distance from the Earth. Stars are grouped into 7 main classes: O, B, A, F, G, K and M. Stars in the O class are the most massive and hottest, and stars in the M class are the smallest and coolest. If you look closely at stars in the sky, you may notice that they are not all the same colour. Some appear redder and some appear bluer, the colour set by the star's temperature. Hotter O stars glow blue, and cooler M stars glow red. This is similar to when you heat up metal to very high temperatures. As the metal heats up, it will start to glow red. As it gets hotter, that red becomes more yellow and then white. Eventually, the metal will be hot enough to glow a bright blue. Our closest star, the Sun, is a G-type star and shines with a yellow light. Next time you look up at the night sky, try to notice the subtle differences in the light from the stars you see. Light can tell us so many things about what lies above us in space.